So the unnecessary cumulative updates should not be generated and stored. So cumulative updates is one of the main drawbacks of this consistency model. Now we want to see how actually release consistency model works. This is actually the latest release consistency model, the latest and updated one. So how LRC works, we can see this. If node 6 has that one file that wants to access by node 1, then node 1 generates a request to DSM manager, distributed shared memory manager, that I want to get the access of the node 6 data. Then DSM manager of node 1 requires that yes, node 6 has a DSM manager and contains the data, and we need to replicate and migrate the block of node 6 to node 1. Then the data has been replicated and migrated to node 1. In this way, node 1 can get the access of writing this data. Okay, what happened? When he is writing on the data, he logged the system that I am writing on this, I am locking the system. This block is written by me, so no one can access this. You can read this, but you cannot write this because I am writing. So sequential consistency has been ensured. Now, if node 2 wants to read, it can read because it doesn't hamper the consistency. So node 2 get a replica from node 6 for reading the block. The replica should be transmitted to node 2. And node 2 can read now. Now, by this time, node 1 completed the writing of the block, and the variant has been vanished. So anyone can now write on the block. Now, if node 6 want to write, you see that already node 1 has modified the data. So I need the last modified data. So the modification of the replica has been transmitted to node 6. Now, node 6 want to write in, no one can write. This is the mechanism of this consistency model. And now, if node 2 again want to write, this is the main problem. How cumulative update has been generated in this consistency model. Node 2 sees that actually node 1 has the updated data, node 6 has the updated data. Two updated data that are cumulative, that will be generated and updated to node 2. So DSM manager collected updates from node 1 and then node 6. So actually we don't need the node 1's update, we need the node 6 updates only. If we get the node 6 update, then it will be have no problem of continuity update. Now we see how LUC model overcome these problems. Suppose node 1 want to access the data, DSM manager send a request. Now the data has been replicated and migrated to node 1. And node 2 wants to write, send a request to node 6, get the replicas, and get the write. But in release consistency it is not possible because concurrent write has not been provided for maintaining the sequential consistency. But how LUC model maintains the consistency is the main thing. Now node 2 has completed writing. But node 2 should not be completed writing before node 1 because node 1 was the previous one. So node 1's writing has become the obsolete write. So this obsolete write should be omitted. Node 2 has declared this somehow has done obsolete write and informed them that the obsolete write should be removed. Then node 1 complete writing, data has been generated and obsolete write removed from the system, and the last updated only data should be delivered to the node 1. In this way, only the last updated data remains in the system and no cumulative updates have been propagated. In this model, LUC model, last update concept, this is the matrix how the system has been worked. These are the request type from C, P3, P1 has request for write operation, but P1 has write previous before P3. So P1 has declared that it is a obsolete write, so it has been This is the LUC algorithm, how it is worked. We are describing the visually the read operation or performs in the proper way that the LUC model works. But in write operation, the first block operates for absolute right, and then the last one operates is either it is absolute right or not. Then this is the analytical performance. So here we can see that LUC model, release consistency model, generates a cumulative propagations, but the last update model remains only one block. That is the last update. So cumulative updates is not being done, and network traffic has been reduced. Now the performance analysis, see what result. We can see the response time analysis, the LUC model when node was been increasing, show the better performance than AC model and RC model. This is sequential consistency and release consistency. Network traffic also has been reduced in LUC model rather than sequential consistency model and release consistency model. The improvement of sequential consistency model over is still there, around 24.5% and around 33% for response time. Network traffic was 23% and RC model network traffic was 45%. So all in average, we can see LUC model scores better or perform better than release consistency model and sequential consistency model. So it has been concluded that LUC model, last of the consistency model, should be optimized rather than AC model and RC model in the basis of response time and network traffic. So in future work, we will try to implement LUC model or object-based DSM so that we can reduce the fault sharing. One of the major problem of distributed shared memory, if we can reduce the fault sharing, then thrashing should be reduced. So it is our future work that we will implement LUC model for object-based DSM. So it is the end of our presentation. I will be glad if you have any questions from my side. Any questions?
Question? Have you used any concurrency toolkit or anything for the experimentation or just implemented?
No. Actually, we don't use any concurrency tool for experimentation. Actually, we work from the software level or application layer Dhaka. So we don't use any concurrency work on the lower level of Dhaka. And this was this work is being done on based on the application layer. So we don't consider any kind of third party or original software. It means that if underlying consistency, underlying system has been done, the application layer works the everything work of the consistency. Actually, this is a proposal for how the LUC model or timestamp based model can improve the existing RC model and sequential consistency. Actually, consistency model is very much older terms. Nowadays, we are just trying to implement this, but the main motive of